right, investigation 2.3. Before I start, a couple notes. The materials say you will need the velocity sensor for this lab, but if you flip through the document, you'll see they don't use the velocity sensor, so don't worry about that. Second off, it mentions not needing to put marbles in. You don't use marbles at all for this lab. They're gonna get to using marbles with the cars coming up here soon. All right, so this lab here is going to be their first actual calculation of acceleration. And so they're gonna use this setup here. Photogate A is put at the 10 centimeter mark. That's how it describes to put it. Photogate B, this one will move. So my blue one's gonna move, again, doesn't matter which color. But it starts off at 20 and you're gonna move it from 20 to 30 to 40 to 50 and so on. It does say to put this up at the 6th hole on the stand. That doesn't show up well on my camera, so I've left it lower for my purposes. What you should notice is that this first photogate, when you set up the car with your stopper, the car is gonna hit that first photogate pretty early, and that's to make sure that we kind of get a starting velocity that's slightly above 0. And then this guy is gonna be, as you move it down the ramp, you're gonna get higher and higher velocities. So let's actually jump in there, look at some sample data. Again, you're gonna see your time at A, time at B, time to AB. I'm gonna release, get our measurements. I explained this in a previous video, but in case you didn't watch that one. Time A, and you wanna make sure that you've got these in the right locations. If your time AB is negative, you probably have these guys flip-flop. Just switch your chords around. Time A, I'll use that to calculate my speed that I was at here. It's how long it took for it to go through that laser. Time B, same thing, but for this sensor. And then this measurement here is how long did it take to go from this sensor to that sensor. Sort of like an average velocity. So the setup is pretty standard, pretty easy. Your students are mainly gonna be doing a lot of data collection in this lab. And so they're gonna mark down, okay, what was my time in this setup for photogate A, photogate B, and my time from A to B. They're essentially gonna be copying down what is posted there, and they'll use this to calculate the velocity over on table 2. So they'll use time for A to calculate the velocity at photogate A, time for B to calculate the velocity at photogate B, and then using those change in velocities over the change in time, which will be from here, they'll be able to calculate the acceleration. So definitely have your students using both of these at the same time. You might want to have your students collect all the data, and then you guys kind of do a few together and then turn them loose to calculate the rest of them. But what they should see is some consistencies with the acceleration. And then down here is making a graph. If you've been talking about graphing, this will be a good test of their graphing ability. And you see a lot more questions. So and this last page is analyzing your data error. You know, if you're not worried about that as a concept, this whole last page can just go. I think that's kind of a high level. So if you got an honors class, maybe you talk about that. Otherwise, you could stop right there. All right, pretty standard setup, pretty standard lab, but it does have some good data collection to talk about acceleration and how things change as this moves down the slope. So I hope that was a good setup video for you guys.